Hi everyone, I'm Swaetha. Welcome to this video. I hope you're all doing well. This video is going to be very generic in the sense that we're going to dive into the very basics of astronomy, astrophysics, and cosmology. So, what do these three terms mean? Are they the same or are they different? Let's find out. Let's start with astronomy that we all know and love. It is defined as a natural science that studies celestial objects such as stars, planets, galaxies, and space in general, and their underlying phenomena. Astronomy is old, it's ancient, and in fact, it's one of the oldest natural science to exist. And we know some pretty famous astronomers such as Kepler, Galileo, William Herschel, Aryabhatta, and many others. And all of them have made some pretty significant contributions to the scientific community and also made some amazing discoveries. And get this, only with their naked eye. How amazing! And some of them were even before telescopes were known or made. Think about it for a second, let it sink in. Cool, isn't it? But in layman's term, astronomy is more on the observational side in the sense that you measure the positions of astronomical objects and compute their motion. So you grab a telescope, go to your backyard, point it at the night sky, and anything that you see, which is basically everything, falls under the category of astronomy, or at least that is what it was known or said to be in the olden times. But in the modern world, in modern physics to be exact, the window between astronomy and astrophysics is kind of blurred in the sense that you can say both of them are synonymous. There is no real distinction between both of them. But to be simple, and let's be honest, we all want to be simple, I would say that astronomy tries to answer the question of what is the position of so-and-so object in the night sky, or where is it located. For example, where is this star located in the night sky? What is its position? What are its coordinates? Whereas astrophysics, which is a branch of astronomy, makes use of this information and uses physics to analyze this information, and in the end tries to answer the question of what are these objects made of, what is it comprised of, how does its spectra look, and so on, which is also pretty important.
Hey, so you have just learned about astronomy. Now we'll tell you about astrophysics. So astrophysics is also one of the most interesting branch of astronomy, and what make it different is the core part, the subject that we are more concerned in astrophysics, which is more theoretical and more physics and chemistry based. So for much of the time prior to Newton, astronomy was concerned about motions of heavenly bodies, for which they used mathematical models, but they didn't have a physical basis. But Newton, using his three laws of motion and law of gravitation, explained the orbits of moons and planets in space, which can simultaneously be used to describe the trajectory of a cannonball on Earth. So astrophysics employ the method and principles of physics and chemistry in the study of astronomical objects and their related phenomena. So basically, we are more concerned about the motion of astronomical objects rather than their location and their motion. Astrophysics concerns general relativity, which was given by Albert Einstein, and nuclear physics as two important tools to describe stars or galaxies. Majority of astrophysical observations are made using electromagnetic spectrum. Emission from these objects are examined across all the wavelength of electromagnetic spectrum, and the properties which are examined under astrophysics may include their luminosity, their density, temperature, and their chemical composition. So perhaps what most completely separated Newton's model from previous ones, as I described just a minute ago, was predictive as well as descriptive. And based on the aberration in the orbit of Uranus, astronomers predicted the position of a new planet, which was then observed and named Neptune. Being predictive as well as descriptive is a sign of mature science. And astrophysics in this category. Well, astrophysics emerged more evidently when William Wolstone and there was one more famous scientist, Joseph van Fraunhofer, who discovered the dark lines in the solar spectrum. What's that dark line? Well, that's basically the emission spectrum of helium, which till then they didn't know the element helium. So this was an instance where the helium was discovered. So but if we talk about now in the 21st century, the study of astrophysics is not so limited. It's go beyond what we have talked about, beyond physics and chemistry. It may expanded from the study wavelength of radio waves, X-rays, and gamma rays to gravitational waves, which we have just recently discovered. So astrophysics more inclined towards the theoretical physics and chemistry. Well, that's it for astrophysics.
So previously you saw what astronomy and astrophysics are, right? And there is another branch in astronomy known as cosmology. And it basically deals with the origin and evolution of the universe from Big Bang to today and into the future. And according to NASA, the definition of cosmology is the scientific study of large-scale properties of the universe as a whole. And you might have heard or seen in movies concepts like dark matter, dark energy, the multiverse, etc. So all these topics are studied under cosmology by cosmologists. And while other aspects of astronomy deals with the individual objects and phenomena, or say collections of objects, cosmology spans the entire universe from the birth to death. And humanity's understanding of the universe has evolved significantly over time, right? And until the 16th century, Earth was regarded as the center of all things, with planets and stars orbiting us. And it was a Polish scientist, Nicholas Copernicus, who suggested that the Earth, along with the other planets in the solar system, in fact orbited the Sun, and which this created a profound shift in the understanding of the cosmos. And then it was late in the 17th century, Isaac Newton calculated how the forces between the planets, especially the gravitational forces, worked. And it was by the dawn of the 20th century, Albert Einstein proposed the unification of space and time in his general theory of relativity. And in the early 1900s, scientists were debating whether the Milky Way contained the whole universe or if it was just one of the many other galaxies. And it was Edwin Hubble who calculated the distance to a fuzzy nebulous object in the sky, which happened to lie outside the Milky Way galaxy. And this could only mean one thing: our Milky Way was just one of millions of galaxies in the enormous universe. And using general theory of relativity to lay the framework, Hubble measured other galaxies and determined that it was moving away from us. And this proved that the universe was not static but expanding. Now, there are a lot of cosmological missions and instruments that help us understand the cosmos. Some of them include NASA's Cosmic Background Explorer, or the COBE, NASA's Hubble Space Telescope, NASA's Wilkinson Microwave Anisotropy Probe, or the WMAP, and European Space Agency, or the ESA, which is still continuing the study of cosmic microwave background. Now, what is the cosmic microwave background, you might ask? So the cosmic microwave background, or in short, the CMBR, is a faint electromagnetic radiation that is a remnant of an early stage of the universe, filling all space. And it represents the heat left over from the Big Bang. And the radiation is mostly visible in the microwave part of the electromagnetic spectrum. And this existence of this radiation has helped us to hone our understanding of how the universe began. What came before the Big Bang? Where did the Big Bang happen? How old is the universe? Will the universe end? If so, how? These are some of the most common cosmological questions scientists are trying to answer. And to know how we can answer these questions and more about astronomy and astrophysics, make sure to subscribe to our page and keep in touch with Astrophysicasts. So we'll be back with another video soon. Until then, bye-bye.